So what is coloring problem? In graph theory, the coloring problem is the challenge of assigning colors to the vertices nodes of a graph so that no two adjacent vertices share the same color while minimizing the number of colors used. This is formally known as vertex coloring and is widely studied in mathematics and computer science. The coloring problem in graph theory is about assigning colors to parts of a graph while following certain rules. In vertex coloring, which is the most common type and the one used in this project, each node or vertex is given a color in such a way that no two connected nodes share the same color. The goal is to use the fewest number of colors possible, and this minimum number is called the chromatic number. There are also other types of graph coloring. In edge coloring, colors are assigned to the edges connections instead of the nodes, and edges that meet at the same node must have different colors. In face coloring, which applies to maps or regions, colors are given to areas and neighboring areas must be colored differently. This relates to the four-color theorem, which states that any map can be colored using no more than four colors so that no two touching regions share a color.
In this animation, the graph coloring problem is demonstrated using a 5-node graph where countries are represented as nodes and borders as connections. The challenge was to color each country using only 4 colors while making sure no two connected countries shared the same one. Imagine you're designing a political map and you need to color the countries so that no two neighboring countries share the same color. This is an example of the graph coloring problem, a concept used in cartography, scheduling, and networking. To understand this problem better, let's convert the globe map into a graph representation. Here are selected countries. For example, each country is now a node and every shared border is an edge connecting two nodes. Our goal is to color this graph using the fewest colors possible, ensuring that no two connected nodes share the same color. Now, let's solve this coloring problem step by step. First, we assign red to the bottom left node. Since the bottom right node is directly connected to it, we cannot use red again, so we put the other red on the top. As we continue, we instead put blue in bottom, and moving up we color the right middle as yellow, then left middle node green, ensuring it doesn't match its adjacent red node. Finally, the top node is colored red again because it is connected to green and yellow, but not another red, ensuring all rules are followed. By following these steps, we solve the coloring problem correctly using only 4 colors: red, blue, green, and yellow. With careful planning, we have successfully colored this graph using only 4 colors. This means the chromatic number of this graph is 4, the smallest number of colors required to ensure that no two connected regions share the same color. This technique is widely used in map coloring, scheduling, and even optimizing network traffic.
That's all the video animation indicate modeling from real world to graph.